Okay. This problem is from So You Think You Can Graph. It is number 2, actually, not number 1. And let's start by drawing a picture. So if we've got this road, okay, and we are going to walk eastward, okay, then I think of that as to the right. So I'm going to draw that. We see we have a constant speed here. So the eastward indicates direction, and then we have the magnitude or the speed is 5 km per hour. Okay, and then you are walking toward your house. So let's draw your house over here. Okay. Then at the same time, your sister is going to drive the other direction. Oh, here, let's just mark that east this way, and that is, let's make that the positive direction. Okay. And then your sister's driving. She is gonna get in her car and drive westward. So they give you the direction and her speed, but since she's driving westward, that is the negative direction. Okay? So it's really important for you to put the negative sign in front of that speed because the speed is always positive, it is a scalar, but when I write the velocity down, I need to include the sign, and in this case that is a negative number. And then it also tells me the distance from where I start to the house. So I'm going to need, it tells me to draw the picture, it tells me to use the house as the origin. So basically, where the car is starting, that's going to be 0. And then that means on my number line, I'm starting on the negative side of the house, right? So I'm to the left, or to the west. So let's write that as my location is negative 3.5 km. Okay. So now, as I'm solving the first part of the problem, let's write down the givens. I know my initial position is negative 3.5. I am walking home. So my final position is 0. And then, of course, I wrote my speed already. It's kind of redundant to keep writing this. That's positive because I'm going in the positive direction. And I am trying to find the time it's going to take me. So I'm going to use the good old formula. Velocity is displacement over time. Or this time I might use df minus di, remembering to put those in the correct order because that matters. So when I substitute these in, okay, what I'm going to have is 5.0 km per hour equals 0 minus negative 3.5 km over delta t. Then I'm going to multiply both sides by delta t. Divide both sides by 5.0 to get my answer. Okay? Remember, there's a couple steps when you solve for delta t. Not just as simple as a multiplication or a division. I need to do the algebra correctly. So I'm going to get a positive answer, which is 3.5 divided by 5.0. Okay, 3.5 kilometers over 5.0 kilometers per hour, which gets me 0.70 hours. Okay. It should be less than 1, because I know that I have less than 5 kilometers to go. Alright. Then, let's look at my sister. She is in that same amount of time, meaning in that 0.7 hours, where will my sister be? Okay, so she is starting at 0 at the house. basically. Um, she is, I am looking for where she will be, and then I know her velocity, and I know the time, which I got from the previous step. So I can use the same formula. There is another option, by the way. This one is in your notes. df equals di plus b times delta t. That's okay to use. But if you want to go ahead and use this one, okay, that's fine too. So let's plug into negative 17.5. Oops, wrong units. Delta T, 0.7 outlet. So I'm going to multiply both sides by 0.7, and I'm going to get a negative answer. So delta D is negative 12.25 is what my calculator gives me. But I only have 2 sig figs available to me because of that time. So then I'm going to get negative 12 kilometers. Okay. Well then, what is delta? But I was looking for df, right? So then, this is equal to df minus di. That's the definition of delta d. So what I'm really saying is negative 12 is equal to df minus 0, because that's where sister started. Okay. So then that is df, right? Okay. That's fine. So now it wants me to sketch the graph. So let's do that. Because I have some points now. Okay, let's list the points that I know. For me, I think I'm switching out of this really wide marker. So for me, I know a couple of points. I know that at time 0, I was at negative 3.5 kilometers. That's my y-intercept. Okay. I also know that at 0.70 hours, I was at home. And I only need 2 points to make it a line. For my sister, I know that at time 0, she was at home. And then at 0.7 hours, she was at negative 12. So that's it. That's all I need. So I have my points, and I'm going to plot them. Okay. Hopefully, oh yeah, it has some labels down here. I can barely see now. Okay. And I think on your copy, it's labeled, like, this is position in kilometers. And this is negative, it goes by negative 3s. We're going to try to keep this nice and even. And then we have time going down here. Alright, so then, for me, here is negative 3.5, like really close to that. And then 0.70, there's my line, okay? Try to make it straight. Ooh, I missed. Let's try that again. There we go. There I am. And then sister, okay, here she is, 0, 0. Love that one. Easy. And then 0.7, negative 12. Okay, draw that line. Okay. That's what we got. For sister, she could probably, maybe her line keeps going, okay? Keeps driving, we don't really know. For you, I suppose, I shouldn't have anything after here. I assume when you get home, you stop moving. Okay.